Good morning, my dear students. I welcome you to NEET World. So in this session we will be discussing haloalkanes and haloarenes. Okay, so this chapter we will be discussing using top 15 important questions. I mean previous year questions of NEET and JEE. Okay, so this session will be definitely gives you some clear-cut approach towards problems or questions of this haloalkanes and haloarenes chapter. So follow the session till the end so that you will feel confident when you see the questions from this chapter. Okay, so let's begin this session. And before beginning this, so I just wanted to tell you about NEET 2026 long-term program. We are going to launch it today, I mean July 1st. Okay, so now very few seats are left. Okay, so if you are interested to join this, feel free to contact the mobile number which is scrolling on your screen. Okay, so in this session we will be providing one-on-one mentorship as well as clear-cut explanation of each and every topic, and especially focusing on weak areas of that particular student. Okay, because you might be prepared previously but not to the mark, right? So in this preparation, in this attempt, you are going to give your best from the best guidance. Okay, so these things will definitely help you. So if you are seriously preparing for NEET 2026 or few students who are preparing for JEE 2026, so these programs, long-term programs, are designed for them. So you can approach us if you are really seriously preparing for that. So you can contact to the mobile number you are seeing on this scrolling, right? Okay, so let us begin the session. So here, and guys, the batch, whatever the fee which is very affordable for this particular batch, see 3333 is a fees for both long-term JEE and long-term NEET. Okay, if you are interested you can reach us. Okay, so now here look at the question number 1 here. See, the ease of ionization to produce carbocations bromide ion under the treatment of Ag plus will be maximum. For which of these 4 options will have maximum ionization ability, which is easily ionized when we treat with a silver ion. So whenever we treat with this compound with silver ion, so what it will be forming? AgBr. So it will forming AgBr, like precipitate will be taking place, and Br minus is coming out and pairing up with the cation, and this anion will get AgBr product, salt. Okay, so along with that we should get a carbocation here. Since bromide ion is more electronegative, bonded electrons will be taken by bromide ion and we will be having a carbocation like this, right? So now we need to check for the stability of these carbocations which are forming from these 4 options. Okay, so now which is giving more stable carbocation? Okay, so that will be easily forms respect to carbocation. More stable the carbocation, more easy to ionize for that particular compound when we treat with Ag plus ion. So this is a concept you need to use here. I hope you know little bit about aromaticity concept, right? So you can apply this aromaticity concept in order to understand this question. See, after removing this bromide ion, we got a carbocation like this, cyclopentadienyl carbocation, which is anti-aromatic, right? Highly unstable. This is highly unstable. Okay, because it is anti-aromatic compound. Now if you remove this bromide ion from here, so you will be getting a positive charge here. So now look into it. See, these 2 pi electrons which are at conjugative position with these lone pair electrons. Okay, complete system is in conjugative position, cyclic compound, right? And now it has 6 pi electrons. See, 2 pi electrons here, again 2 pi electrons here, and these 2 non-bonding electrons, right? Total 6 pi electrons are there which are in continuous conjugation, right? So this system is what now? This system is what now? Aromatic compound, right? Aromatic carbocation. So aromatic carbocations, like aromatic species, are highly stable. Therefore bromide ion from here easily goes out, right? Respect to carbocation is highly stable. Therefore I can say this molecule will be easily ionized when we compare with the first one. Okay, because due to its stable aromatic nature. Okay, hope this is clear now, right? Now look into this. Now if you remove this is aryl halide, like benzyl bromide, na? So if you remove this bromide ion, you will be getting benzene with a positive charge. Phenyl carbocations are highly unstable, therefore this bromide ion will not comes out. So ease of ionization is very difficult here. It is very difficult to ionize, so it won't become ionized. Okay, so 2 is easily ionized. So similarly, if you compare this fourth one, now this can be removed as Br minus and you will be having a positive charge. Okay, now this positive charge can be stabilized by this lone like pi bond electrons by conjugation like this. So I can say this kind of systems as allylic systems. What is that? Allylic systems, allylic carbocation. So allylic carbocation is stabilized by its conjugation like this. Okay, it will be shifted here like this, positive charge will be here. Okay, so like this it will be stabilized in the fourth option. Okay, so now there are two compounds which are highly stable, but relative stability if I ask, you should say second carbocation, the carbocation generated in the second compound is highly stable because of its aromatic nature, and after that fourth option. Okay, so I can compare 2 and 4, out of that 2 is more stable, therefore our answer will be 2. Hope this is clear, which is easily ionizable, right? Yes, if it is clear, please tell me in the comment box, clear sir, right? Clear means clear. Yes. Now you can also click on the like button if you are really interested or if you are really liking this content. Yes, let's move further. Yeah, so now what is the basic concept here you need to remember? It's aromatic nature application only, right? Then next, yeah, look into this again. Identify the correct order of reactivity in electrophilic substitution reactions of the following compounds. Yes, so which is having more reactivity towards electrophilic substitution. See, given 4 are aryl compounds like benzene rings, right? So to that we need to add electrophile like this. So electrophiles are nothing but electron deficient. So if this is electron deficient compound, our benzene ring, our substrate should contain electron rich, right? So if it is rich, electron deficient species can easily attacks on that rich site, right? So now you compare, here we have nitro groups, right? These are strong electron withdrawing groups. Okay, so here we have chlorines and here we have methyl group, ethyl group, alkyl groups. We know alkyl groups are electron releasing groups, right? So now you tell me, so based on this electron withdrawing, what it will do? It will withdraw the electrons from the ring, so it will decrease its electron density from the ring. Therefore the very least reactive is 4 towards the electrophile, because this is electron deficient. Our ring has to be electron rich, then substitution takes place readily. But due to presence of this electron withdrawing group, the electrons from the pi electrons from the benzene ring is dragged towards the electron withdrawing groups and creates the electron deficiency, right? So fourth option is least reactive. See, least reactive you have in option number 4, 3 and 1. Okay, and after this what you need to know? See, here you have electron releasing group, right? Here you have electron releasing group and here you have chlorines, okay, which are having little bit minus I nature, right? So out of this alkyl group is this one, this is strong like electron releasing group, therefore this will releases the electrons into the ring. It means electron density within this ring is increasing, the electron richness is more in option 2. So therefore option 2 will be readily takes this electrophile, right? So electrophilic substitution will be takes place readily in second option, okay, and least in fourth option. You can fix it like this. And out of these, benzene is more reactive than this halobenzenes, okay. So due to its minus I nature, therefore I am writing here 1 and after that 3. Hope this is clear. So 2, 1, 3, 4. Our option number 3 is perfect answer for this question. Hope this is also clear, right? Yeah. Let's move forward. Yeah. So now tell me where this electrophile will attach. So it will be goes either to the ortho position or to the para position. Okay. So why? Since it is electron releasing group, it will increase its electron density by this pi electron shifting to this ortho position. We will be getting a negative charge here. So negative charge, positive charge. So we'll make a bond and form a substituent here like this. Okay, so it is electron releasing group we have now. So it is like this. So electrophile here. So these pi electrons are donated to the electrophile and forms something like this. Okay, so look into it. So now it is a carbocation, so which is sigma complex, I can say. Now this will be regain its aromatic nature by removal of this H plus ion from here. So finally we will get a product, ortho product like this. Okay, and we similarly will get a para product also by reaction at para position here like this. Okay, so out of this para is major and ortho is minor. Hope this is an extra discussion. Hope it is also clear. And you know, if you want clear detailed discussion of this haloalkenes and haloarenes, just go through the playlist where I have explained everything clearly regarding this haloalkenes and haloarenes chapter. So just go through the playlist. You can watch whatever the topics you want from this channel. Okay, so I have discussed it personally, so you can definitely like that and will be helpful for you. Okay, just go through it. Okay, now let me go for the next question. Yeah, look into this. Which are the following order is correct for decreasing reactivity to ring bromination, monobromination of the following compounds? Okay, so just give the reactivity order. See, ring bromination means definitely if anything happening in the ring means that should be definitely what? Electrophilic substitution. It means it should happen by substitution reaction only, either electrophilic or nucleophilic. So generally here in haloalkenes, like here halogenation is electrophilic substitution reaction, aromatic electrophilic substitution reaction. So we have a benzene ring like this. Okay, so for this they are saying ring monobromination. It means we need to add bromine to this. Okay, this happens in presence of iron like this. Okay, so what will be the product here? So you will be seeing something like this, monobromination means. Okay, these are the substrates given. Instead of giving simple benzene, these 4 options are given. So in which option ease of bromination takes place, easily bromination takes place. See, bromination here, bromine electrophile involves here. So it is electron deficient. Our compound substrate has to be electron rich. So which groups will increase electrons in the ring? Electron releasing groups. Say methyl group is electron releasing groups, carboxylate group is electron withdrawing group, and here we have carboxylic acid group, electron withdrawing group, and here we have electron releasing group. Okay, and nitro group, this is strong electron withdrawing group. Therefore ease of reaction electrophilic substitution takes place in electron releasing group containing compounds, that is in 1, right? After this, here we have electron withdrawing group, here also we have strong electron withdrawing group. Here withdrawing is there, releasing is there. So this group is same, but along with this group we have electron releasing group. Therefore I can say third option is relatively more reactive after 1. Then next, out of these 2, I told you nitro group is strong electron withdrawing. Therefore strong means electron deficiency is more in this ring, right? So if it is electron deficient, it will be least reactive. So I can say fourth option is least, and here it will be second option. Hope this question and explanation is also clear now? Yes. If it is clear, please please click on the like button if it is clear. Yes. So who is this? Shashank. Yes, Shashank, you can go to the playlist. I have discussed GOC, general organic chemistry, like inductive mesomeric effect hyperconjugation. Okay, so it means it is almost 2 months back I have discussed. You can watch that basics, that will be definitely useful. Okay, I hope it is clear, Shashank. Yes, let's move forward. This is also clear now? Yeah. Look into this. The major product C in the below mentioned reactions. See, we have propyl bromide. We need to treat with alcoholic KOH. So alcoholic KOH under heating condition, whenever you see it like this, you can think of elimination reaction. Elimination reaction. So elimination reaction, write this thing, CH3, CH2, CH2, Br. Okay. So I am making this like this. So here we have base. So this base abstract the acidic proton. See, this base will abstract this acidic proton. So what happening here, H plus is removed. So these bonded electrons will be donated towards this side. So bromide ion will goes, as it is more electron electronegative group that will take these bonded electrons with itself. So therefore this carbon is getting positive charge and this sigma bonded electrons are shifting into that empty orbital of the carbon. Therefore we will be having a product like this. Yeah. So what is this? This is A here. Okay. To this A we need to add HBr mentioned here. So HBr. Okay. So what is this? Electrophilic addition reaction. So here we know HBr, HCl, HI, all these are strong acids. Therefore it will donate H plus ion. So this will be taken by this carbon, this terminal carbon. H plus ion is taken by the terminal carbon and gives to this carbon. I am adding this terminal carbon, I am adding H plus. Okay, and this will be, see, this is losing the pi bonded electrons. Therefore it should get a positive charge. On this secondary carbocation, this bromide ion will attacks here. Therefore it gives us CH3, CH, CH2, CH3 I am writing here bromide. Okay, so this is our B. Okay, to this B again aqueous KOH. So aqueous KOH means what? Aqueous in the sense here it is alcoholic, here it is aqueous. So aqueous, it means the solvent is different. So in aqueous medium substitution reaction takes place, or substitution reaction is favored over elimination. So what happens here? We have OH minus only, but this is in water medium, like aqueous medium. Okay, so this OH minus act as a nucleophile here and attacks on this carbon, secondary carbon, and bromide ion will leaves out. Therefore we will be getting a product like this, CH3, CH, CH3, okay, here OH group. So this is our product. So what you will get? Like propane with second position hydroxy group. So okay, we can say propane 2-ol. So propane 2-ol. So what is this? 2-propanol or propane 2-ol. So this will be your perfect answer for this question. This is also clear now? Right. Okay. Now let's move further. If it is clear, just tell me clear sir in the comment box. Yeah. So let's move again. So which will the compound that will undergo SN1 reaction with the fastest rate? Yeah. So which of these four options will readily involve in SN1 reaction? So how can we answer these? So this will be based on the intermediate formed in SN1 reaction we can answer. So in SN1 reaction what happens? We will be seeing carbocation as an intermediate. For example, here we have a carbon with 3 alkyl groups like this. Okay, so one halogen. So in substitution reaction what happens? This halogen will goes out first, okay, and will create a positive charge on the carbon, and we are calling it as a carbocation, which is sp2 hybridized, electron deficient. So if this carbocation is tertiary, that will be more readily, like if this carbocation like carbon alkyl halide is tertiary, so that will participate in the reaction more readily because respect to carbocation is more stable. So after this secondary and least is primary, like this we need to understand, because carbocation stability order also follows the same order now based on that. Now if you remove this bromide ion, you will be getting a benzyl carbocation, right? So benzyl carbocation here positive charge is stabilized by this ring pi electrons, and this 3 hydrogens of this alpha carbon, like hyperconjugation taking place, right? So it will be stabilized. So here if it is goes, so what kind of group it is? So this carbon is secondary carbocation but benzylic carbocation. But what about this? So it goes out. Now what kind of carbocation you are getting here? So you are getting primary carbocation. We know primary carbocations are least reactive in SN1. They will proceed with SN2 reaction. Okay. So here it is. See, this carbon attached directly to the 2 other carbons. So I can say this is secondary carbon, and upon leaving this bromide ion we will get a secondary carbocation, which is more reactive than this primary, right? And this is aryl halides. So they won't show SN1 and SN2 reaction. They do not involve this kind of compounds, this kind of substrates do not involve in either SN1 or SN2. So no need of discussing about this. So fourth one is the least reactive. See, they asked us which is more reactive. I can directly answer first one as our answer because respect to carbocation is secondary and benzenic, right? So that is why first one is more reactive. So first one is more reactive, that is our option for this question. Now in the next exam you may also see that they may also ask arrange them in the order of reactivity. In this case what you need to do, so first one is more reactive, after that if you see this is secondary, this is primary, so which is more? Secondary carbocation is more reactive, therefore secondary alkyl halides are more reactive because respect to carbocation is more stable, right? Yeah, so 1, next 3, after that 2, and least reactive is 4. So 1, 3, 2, 4 should be your answer if in case you see this kind of questions in the upcoming exams. Hope it is clear, right? Let's move further. Yeah, so try to answer this, look into it and try to answer that. Yes, so here we have propyl bromide and that should be treated with NaCN. We know Na plus, it is like Na plus Cn minus. So you should say this is reagent and this is substrate. So this attacking reagent, what is the reactive site here? Alkyl bromide, like see this CH2 group connected with bromide, this carbon is a reactive site in the given substrate. Okay, so now what happens? So bromide ion will goes out because it is electronegative, so that will drag the bonded electrons towards itself and creates electron deficiency on this carbon, right? Now any electron rich attacking reagent is there, means that will come and attacks at this carbon because it is electron deficient. So bromide ion is going out, so Cn minus cyanide ion will comes and attacks on this carbon. Okay, so what kind of change you are seeing here? One, bromide ion is replaced by cyanide ion, so it is a substitution reaction. Hope this is clear. Okay, the reaction will be, so this reaction will be fastest in which solvent they are asking. Yeah, so we can say substitution reaction, effect of solvent on the substitution reaction. Okay, so now look into this, what kind of alkyl halide given? So it is given as primary alkyl halide. So primary alkyl halide generally reaction goes with what? With SN2 mechanism, right? So SN2 mechanism favored in polar aprotic solvent. What is that? Polar aprotic solvent. So in the given 4 options, we need to identify which is polar aprotic solvent. See, ethanol, methanol and water, these are protic solvent, polar protic solvent, whereas NN dimethyl formamide is there na, so that is polar aprotic solvent. What is that? Polar aprotic solvent. What is the structure of this? See, NN dimethyl I am saying, formamide I am saying. See, formaldehyde means this is a formaldehyde we know, right? So this is a formaldehyde we know, like HH C double bond O. Now remove one H from here and replace that with one nitrogen amide group you make. Okay, NN dimethyl. So here one methyl and here one methyl. So N on nitrogen 2 methyl groups. So NN dimethyl formamide. So this is polar aprotic solvent. Okay, see it has polar bonds like this. Okay, but it cannot form hydrogen bonds, right? So it cannot form hydrogen bonds. Okay, it cannot donate a hydrogen bond donor is absent in this, so I can call it as polar but aprotic. Therefore our option should be 3. Okay, whereas water molecule if we see, so it will be having polar hydrogens, right? These are like having partial positive, partial negative charge. So this H plus ion can show hydrogen bonding with the other molecules. Therefore this is a polar protic solvent. I hope it is clear what exactly polar aprotic and polar protic. Polar protic means they should have polar bonds and they should form hydrogen bonds, like they should have hydrogen bond donors. See, this H plus ion can form hydrogen bond with the other molecules which are polar, right? Therefore, I can say this is hydrogen bond donor as well as acceptor. So, I can say fourth option is polar protic. Similarly, first two options also, but third option is polar aprotic. So, you have to go with option number 3. Hope this is clear, right? Yeah. So, now if you want more detailed discussion on this SN1 and SN2 and elimination reactions, just go through the playlist. I have explained very clearly about aromatic nature and applications of aromatic nature in organic reactions like SN1, SN2 and other reactions also. Then next SN1, SN2 special discussion I did, separate discussion. See, without whatever the exam you are going to write, without having questions from SN1, SN2 or elimination, there will not be any question paper out of these 4 mechanisms. Okay, so you need to be clear about these 4 mechanisms. Okay, I suggest you to go and watch that videos in the playlist. Okay, those who are chart bugs, especially I am saying for them. Yeah, then next. This is again one of the very important question. Okay, look into it. Benzene mechanism. What kind of mechanism involves here? Benzene mechanism. So look into it very carefully. See, we have sodamide. So this is NH2 minus. It's a strong base. Okay. Now look into the substrate. Where is our reactive site? You need to look. See, you need to understand that this NH2 minus is a strong base, I am saying. Okay. So even if you want to consider as a strong nucleophile, just think with common sense. See, benzene contains these pi electrons now. If this is a nucleophile, if it want to attack on this benzene ring, we know this is electron cloud, benzene also contains high electron density, right? There will be electronic repulsion between the pi electrons of benzene and the negative charge of this amide group. Therefore, this new attack of nucleophilic attack will not take place on the benzene ring, right? Now what is the other possibility here we have? See, now there is no possibility for acting as a nucleophile as from the explanation. Now look into this. Here we have hydrogens like this now. So now this NH2 minus have another property, that is what? Its basic nature. Now due to its basic nature, it will abstract this proton from here, which is acidic, relatively acidic proton out of this mentioned hydrogen. Okay, after abstracting that, we will be having a negative charge. Look into it. OCH3, negative charge here and Br here, like this. Now this is the negative charge formed here. So now whenever it is formed within the spontaneously, this will be goes towards a side where we have good leaving group. Br minus is a good leaving group. So this negative charge will move this side so that this Br minus goes out. Okay, so now we got a benzene benzene intermediate like this. OCH3, okay, like this inside the ring, and here we are making a new pi bond using this negative charge. Hope this is clear. So this is one more type of intermediate, we can say benzene intermediate. So to this benzene intermediate, we have this NaNH2 sodamide. So we have high concentration here. So this NaNH2 minus, okay, I mean NH2 minus will again attach on this substrate, I mean on this intermediate. So now the attack of NH2 minus takes place in such a way, see, this is negative charge, so it should attack in such a way that the charge which is generating on this benzene ring should be stabilized by inductive effect of this OCH3. Now we know OCH3 is minus I group, right? Now minus I group I am saying. So this is minus I group means the negative charge more closer to it, more effectively it will drag the electrons towards itself. Therefore this NH2 minus will attacks here, therefore negative charge will be generated here. That negative charge is stabilized by this OCH3, okay, by minus I effect. Okay, we are getting something like this, OCH3, NH2 here and negative charge here. Okay, so on this negative charge, whatever the proton we have removed, that will be again added here. So we will get a product something like this. So I have mentioned each step to avoid the confusions. Okay. Yeah, so this is our final product. Okay, so now from wherever we have removed bromide, there we added NH2. So wherever the leaving group is removed and incoming group is also added, that kind of product is called ipso product. What is that? Ipso product, IPSO. Okay, now if instead of adding NH2 here, if we add an adjacent carbon, you should say it as syn product, SINE. Okay, CINE. Okay, so this is our ipso product which is formed in this reaction. So where do we have this kind of product? See, in out of 4 options, we have this as our option, okay, as answer, and along with that, so what type of reaction we have seen? See, first of all, substitution, is it substitution or what? See what kind of reaction it is. So I can say it is what? See, elimination of this proton, like see bromide elimination, and the next addition. So that is what? Substitution only, na? See, eliminated and added. See, one is removed and replaced with other thing, means what? It is what? Substitution only, na? That's why it is given as substitution. So this is ipso product formed here. Okay, so ipso and substitution, you can go with option number 4. Okay, so see, in some options you can see syn product is given. So syn, it is not syn. What do we mean by syn? It should be added on the benzene carbon, it should be added the adjacent carbon, not on the same carbon where we have removed this eliminating group. Okay, hope this is also clear now. Right. Okay, so if it is clear, yeah, let's move forward and try to solve this kind of questions, and especially for those who are preparing for JEE, you need to focus on this concept more. See, this is a NEET question, even though they can also ask in both JEE and NEET, even in advance also you can expect this kind of model questions, okay, with a little more difficult level. Okay, so just if you are not clear, just go back to the like 2-3 minutes back and rewatch it, then you will definitely feel clear, and clarity on this concept you will get in that case. Okay, hope it is clear. Let's move further. Yeah, so elimination reaction of 2-bromopentane. Write the structure of 2-bromopentane. This is butane, this is pentane, 2-bromo. Yeah, 2-bromopentane. So giving us 1, 2, 3, 4, 5 pent 2-ene. So I can write like this, pent 2-ene. Okay, what kind of reaction they are only saying? This is elimination reaction. So this kind of product is formed by elimination of this bromide, and from this position we need to remove one more group, that is nothing but hydrogen. So hydrogen, I mean H plus proton and bromine. So dehydrohalogenation reaction it is. What is that? Dehydrohalogenation is taking place. Okay, so this H plus and this Br minus will be removed and will be getting eliminated, and will be getting an answer like this. So I can say this is alpha position where we have bromine, and the adjacent position, this is beta, this is beta. If we remove hydrogen from here, we will get 1 bromopentene, 1 pentene, 1 pent 1-ene you will get, but they are asking pent 2-ene as a product, right? So see, pent 2-ene as a product, it means you definitely remove proton from here only. Okay, so alpha beta elimination from inside. So now whenever you get double bond inside, you should say that is as Sage-Jaffe product. See, they mentioned Sage-Jaffe product following Sage-Jaffe rule. If you get a terminal double bond, you should say it as Hoffman product, okay, or following Hoffman rule. Okay, so this product whatever they mentioned, this one, this is what product obtained by following Sage-Jaffe rule. Okay, so we have seen it is beta elimination, it follows Sage-Jaffe rule, and what kind of elimination? Hydrogen halogen, dehydrohalogenation is taking place. So dehydrohalogenation reaction, it is not a dehydration. If water is eliminated, like H plus OH minus is eliminated, you should say dehydration reaction, but it is dehydrohalogenation. A, B, C are correct, so option 4 is your perfect answer for this question. Hope this is also clear. Now any difficulties, please write in the chat box, I will try to address it. Yeah, yes. So the next one, yeah, so guys, I hope many of you are watching continuously but haven't subscribed the channel till now, right? So I hope you will subscribe by now. At least now itself we will be going and clicking on the subscribe button, so that I can confirm that you will be following our classes regularly and consistently. Yes, if these classes are really helpful for you, please click on the like button and also subscribe button, so that we'll confirm that you are really liking this, and we'll continue to do the sessions regularly if you show that support. And you can also share with your friends. Okay, now let us look into this one last question, and I will show you few other questions also. Okay, so now I will be showing few other questions also. You can try them, and I will be discussing them in the upcoming sessions. One last question we have here is, which are the following compounds is inactive towards SN1 reaction? 4 options are given, which is inactive towards or which is not reactive towards SN1. See, we know SN1 alkyl halides will show reactivity towards SN1 reaction and SN2 reaction, but we know reactivity order is more for tertiary, secondary and primary in case of SN1, right? So here we know this is tertiary carbocation, so it is highly reactive, and see this is primary carbocation. Now if we remove this, we will be getting a carbocation stabilized by this allylic double bond, right? So by allylic stabilization, like resonance stabilization, right? So this is also shows SN1 reaction. And when it comes to this, if we remove this chloride ion, we will be getting a benzyl carbocation, that is also stabilized by this methyl group, as well as the pi electrons of this benzene ring, right? We can say this is benzyl carbocation, so it is also highly reactive towards SN1. Now you need to know about these bridged compounds. See, if you look into this carbon is tertiary carbon. By removing this halide ion, we will be getting a compound like this, This is a tertiary, it is looking like tertiary carbocation, but it cannot be stabilized as we seen in these 3 cases. Okay, so this bridgehead carbocation, whenever you are seeing a positive charge generating on this center, this bridgehead carbon, that will be highly unstable. Okay, therefore that kind of compounds will not involve in the any chemical reactions. These are highly inert. So this halide will not take part in chemical reactions because of the tertiary carbocation which is generating here is highly unstable. Therefore if it goes out, a unstable tertiary carbocation is generated, right? So if it is unstable, so how it will be generated? So it will not be participating in chemical reactions. Okay, so it will stays like this only, it won't react in any nucleophilic substitution reactions when we have a carbocation here. But if you have a carbocation here, like alkyl group, like halide group here, yes, reaction will take place from here. This will be eliminated or it will be substituted by the suitable nucleophile or suitable base, and if it is eliminated, we will get a double bond here but not here. Okay, always remember we should generate a double bond here only in elimination, and in substitution, so you just remove this and replace it with one good nucleophile in the place of Cl. Okay, this is what the story you need to know about this. So if you want to know more about this, you just search it as Britt's rule. Okay, Britt's rule, or you can watch my previous lecture, there I have explained. Okay, now if everything is clear, just don't forget to subscribe the channel and click on the like button, and feel free to give your feedback in the comment box. Okay, the next will be showing you few questions. Try to answer this question. Okay, take a screenshot of this. I will be discussing these questions in the upcoming session. It means tomorrow session I will be discussing this and also this. Okay, along with this I will add few more questions from this chapter to these live sessions. Okay, so do not skip the live sessions, every day join it and you will definitely benefit out of it. Okay, and again evening around 7 o'clock I will be again in the live session with one more good session and with a good topic. So just do join it and you can learn many things out of it. Okay, so thank you for watching, stay connected with us. Thank you.